Hi everyone, I'm Kirk White. Recently at the Flutter Vancouver Meetup Group, I gave the talk Flutter for Web. This is a screencast version of that talk. Flutter for Web can compile the Dart code of your Flutter app down to JavaScript, allowing you to deploy your Flutter app to web servers so that anybody with a browser can access your app. Flutter for Web is in technical preview, and it is not a new way to make websites. Not yet, at least. We'll get into that. Getting started with Flutter for Web does require a little bit of setup. There are minimum Flutter and Dart SDK requirements to be aware of, but the Flutter for Web repo has an excellent getting started section. If you want to work with existing apps, you will need to go through a migration process. This is also well laid out in their migration guide. If you want to start from scratch with Flutter for Web, you can create new apps right within the 3 major supported IDEs. So now that we've got a technical preview, what is it that works? Thankfully, a lot. It's very impressive actually to start up playing with Flutter for Web and to see exactly how much of it is exactly as you would expect. Animations are beautiful and for the most part smooth. We have responsive layout and media queries. Flutter has always had a bit of a flexboxy model for layout, and that works exactly as you would expect here for Flutter for Web. Routing and deep linking do work, but they're not quite ready for prime time yet. We'll take a look at that in a moment. Fonts and assets are handled in a slightly different way, but do work, as do forms and keyboard input. Packages written in Dart should work as expected, and we also have hot restart. We do not have stateful hot reload, though. Dart DevTools works, specifically the inspector and logging tabs, as well as step-through debugging with Chrome DevTools. It's really fun to work on a Flutter for Web app in a browser and to do step-through debugging through Dart code. Flutter for Web is actually a fork of the proper Flutter project. Now, the side effect of this is that it means that any Flutter packages that depend on Flutter, which is all of them, don't actually work because that main dependency is not met. Plugins also do not work. Plugins are often comprised of platform-specific mobile code. So until that is sorted out, plugins also will not work. One fundamental aspect of the web is links, being able to link to any other web page. There's currently no way to actually link outside of your app. Text operations aren't there yet either. Select text, copy, paste, or generally manipulate any text on the screen of a Flutter app. Currently, Flutter for Web uses hash fragments for its URLs. This means that every URL of your Flutter for Web app will have a hash in it. It also seems like accessibility is not fully built out yet and a little bit confusing. Now, we don't yet have stateful hot reload, which is an important part of the developer experience for Flutter apps. As I mentioned earlier, what we do have is hot restart, meaning that the entry point is loaded fresh every time. While we can do step-through debugging in Chrome DevTools, managing that debugging straight from within the IDE is not ready yet. And just a couple of other notable quotes from the limitations section. Not all Flutter APIs are implemented yet, and performance work is only just beginning. I'd recently come across this Planets demo with code by Sergey Martinez and based on a design by Vijay Verma, so I decided to take this for a spin through the migration process. The process is actually fairly simple and can be done quickly. It basically involves doing a lot of search and replace for the Flutter dependencies, so switching the main Flutter dependency to the Flutter web dependency. There's some changes you need to make in the pub/spec YAML, and also some additional handling for assets and fonts and the like. I then threw it up on a Firebase hosting instance, and as you can see, it works really great. There's still some issues with icons apparently, but it's smooth. You can see that we have the hero animations happening as expected, and it looks beautiful. Now, you'll notice the markup here. So the markup for a Flutter for Web app is basically 3 trees made out of a series of custom elements. FLT Scene Host is where all of your actual visual representation of the app resides. You'll notice that it's marked area hidden true. So you can dig down and eventually you'll start getting into the canvases that make the actual app that you're interacting with. Eventually, you'll get there. The second main custom element is the glass pane element. One of the Google engineers described this briefly in a Reddit thread. If I understand correctly, glass pane is the layer of the app that handles input from the user. I believe it's also going to be responsible for accessibility. RulerHost is interesting. It's comprised entirely of divs and paragraphs that represent text elements in the app. And apparently this is for layout purposes, so that the exact size of text elements can be known to the app. So you'll notice this hash at the end of the URL. All of your Flutter for Web apps currently will have this hash. I believe it was a very simple and straightforward way for them to get routing working properly. By having the hash, it means that the browser will automatically ignore everything that comes after it, allowing Flutter for Web to handle its routing internally for its own named routes. So these are actually named routes. This is /Mars, this is /Neptune. I believe it's a bug currently that's not showing up. Can I actually add Mars? No. I'm sure I had this working at one point. So I'm sure that's going to be fixed and is coming up. But you will not be able to get rid of this hash in the URLs yet. Of course, I seem to remember that this wasn't actually good for SEO, so I was kind of curious and just typed in hash URL SEO. And of course, the first thing that comes up is Google itself saying, do not use hashtags in your URLs. So I'm quite certain that the Flutter project will work hard to get that sorted out. Another aspect that we're all curious about, of course, is bundle size. How much JavaScript is Flutter for Web creating to be able to render what it is we want to serve? So this is quite a trivial app. It does nothing but what I've shown you. I believe if we do a refresh of network here, so this basic app weighs in at about 507 kilobytes. Just out of sheer curiosity, I went ahead and kind of rebuilt the main view just to see what the difference would be. You know, you're going to get this coming in at about 100K. So of course, this is a reminder that there are costs to using Flutter for Web. And I'm sure Google would be the first to agree that if all you need to do is create a website, nothing is going to beat HTML, CSS, and JavaScript. It would be really cool to do a proper apples-to-apples comparison, a native version of a non-trivial app compared to a Flutter for Web version compared to another front-end web work, something like React or Vue. That would be a great project to see. I mentioned earlier that you can start a new Flutter for Web app from right within your IDE, so let's take a look at that. So the slides for this talk are done as a Flutter for Web project, which I already have open here in VS Code. I'm simply going to run the new web project command. I'll say Hello Vancouver as the name of the project. Where we can save it. Let's throw it on our desktop. Okay, we've got all of our packages and we're ready to go. Let's take a look at what we have here. PubSpec YAML, as expected, you'll notice that we have our minimum requirements met. You can actually just simply add these dependency overrides to your PubSpec. This avoids having to download the fork and mess with your existing paths on your system. We have a main Dart, which simply does some web-only initialization and then calls the entry point of your app itself, which we will find in lib, just as you would expect. You'll notice here we also have a web folder. This includes the index.html for your project with a reference to main.dart.js. This will be the compiled output from your Flutter for Web project that will be able to run in any browser. Now, there are two different ways that you can run this project. WebDevServe with the auto flag set to restart will create a project on localhost 8080, which you can open up. You can see here we have our demo app, and if we make some changes to this app, let's simply change our... You'll see that this reloads automatically. Now, as I said, this is reloading your entry point fresh, so this is not stateful. The one problem you have with this setup is that you cannot actually use the Dart DevTools. At least DevTools doesn't seem to be available in this situation. So another thing you can do is actually start it a different way. If we start the Flutter project from within the IDE itself, it will be set up and connected to the DevTools instance. So if I go back here and where's our debugging? You can see that's running as we'd expect. And now within the command, I actually have Dart tools available to me. So we have access to the tree. The problem with running it this way, though, is that now we don't actually have hot restart anymore. We make changes, the project will get rebuilt, but you'll see that it's not actually refreshing as it should be. Now, I really like having access to Dart DevTools. I find it to be really important for my workflow. So what I did to compensate for the loss of hot restart was to actually use a file watcher. And a file watcher is simply a small program or utility that you can say, hey, watch these files. If they change, perform this action. I often use a tool myself called File Watcher that I configured to simply refresh the currently active tab in the browser. By starting your Flutter for Web process from within the IDE, then opening Dart DevTools, while having this File Watcher running, that gives you the best of both worlds. You'll get that hot restart while still having access to Dart DevTools. So now that we've seen what Flutter for Web is currently in the technical preview, what are we going to get in the future? A top priority for the team at the moment is getting the fork merged into the actual proper Flutter repo. Once this is done, all Flutter packages will automatically start working again because that main dependency of Flutter can be met. We're going to need a working plugin system, so that is also a high priority for the team. And just as we can use plugins now to interact with hardware on mobile, we'll be able to, in the future, use web APIs to interact with local hardware through Flutter for Web. I'm sure the future will bring many improvements in accessibility and text handling. These are two fundamental aspects of using the web, and that's not something that Flutter for Web is going to want to leave behind. As we all know, performance work never ends. And one thing mentioned by Kevin Moore is I believe he's a product manager for Dart. In a recent podcast, he mentioned that when we have the ability to control the output of our projects, as we do with Flutter for Web, there's no reason why we couldn't automatically prepare that output to be a valid PWA, a valid progressive web app. That in itself, to me, is very exciting for the future of Flutter for Web. Even though it's only a technical preview at this point, Flutter for Web is very impressive. It is a lot of fun to take that premium developer experience that we expect with Flutter and to be able to use it to craft sites that anybody can access from the web. While it may not be the perfect option for all situations, Flutter for Web is going to be an excellent addition to our toolkit. And once the rough patches are smoothed out, I think we're going to see Flutter used a lot more in a lot of situations. Thanks for watching, and leave any questions you have in the comments below. See you next time.